all right. Yeah, let's turn on the music. I like the music. Where's the music? What time do you have to go, Jamarcus? So I know to rush on questions. Okay, in an hour. That's cool. Dinner whenever my dad wakes up. Okay. Your dad like sleep in the afternoon? Kind of late. I guess maybe he has like a late job or something. Or early job, I guess. Your dad sleeps? Justin would be like, wait, you have a dad? That's wild. That's wild. What's up, monkey? How you doing? You okay? Monkey, how are you doing in your classes? Are you like just like super smart? You never need help? Yeah, so Jamarcus, what are these notes? What are they from? You showed me to them. These? Pretty cool. Oh, it's the research mentorship. Oh, that's very cool. Okay, very cool. Yeah, this is cool. Euler's formula. Yeah, this is how you can represent complex numbers in It's really components is what it is. I think it is, right? Yeah, polar form. Yeah, a to the BII. Mm-hmm. Yeah, z is the modulus, which is, yeah, whatever, the magnitude. It's like the radius of it. It is. Yeah, no, this is super important when it comes to, yeah, complex numbers and because you start doing things in what are called like the complex plane. Just, you know, you have like a real axis and an imaginary axis. And it is very useful for like trig and whatnot, for sure. Yeah, use a lot of trig. A lot of sines and cosines. All right, let's see. Let's dive into some of the questions you have here. I'm curious about them. We'll see how they go. All right, let's kick it off. All right. Welcome to everyone's office hours. My name is Dr. Goldensack, Education. Streaming helps you out with math homework, science homework, all sorts of stuff. Happy Tuesday. Hope you guys had a nice break yesterday. Monday was nice, right? Technically a day off. I went running with my crew. Why do you use log to find the half-life of an element? Oh, that's very cool. That's because when things like split, like every certain amount of time they split in half. That's what a half-life means. Half-life means is how much time does it take for half of the amount of stuff to go away. So if we were to like look at a graph of something like this, let's say this is like time, right? And this is like the amount of stuff, okay? Let's say you started like 50 stuff, right? And then you're going to get down to like 25. Well, here, let me like make this like an actual graph. Sorry. 10, 20, 30, 40, whatever, 50. Get rid of this one. Okay. So if you started, for instance, here, Nick, with like 50 of something, and then after a certain amount of time that cuts in half, you would have 25 of it left, right? This would be like this would be at like one. We would say like 1 half-life. I think this is what we call half-life, right? Is that you guys call lambda half-life? No clue. Okay, whatever. We'll say 1 t 1 half, 1 half-life. You can say, for instance, let's say like the half-life here, right, is whatever, like 10 minutes. Okay. So then how much would I have 10 minutes after that? Like another half-life. Yeah, T1 half is what you guys use for half-life. That's okay. Yeah. So let's say I started with 50. 50 to start, right? And then here, right, I had 25 after 10 minutes. How much would I have 10 minutes later? 12.5. Oh, good. So I'd be like right here. Right? Let's be like 12.5. And then let's go another 10 minutes. How much would I have left then? Does it ever get to 0? Technically, no. It'll get very close, but technically it doesn't actually get to 0. Yeah. What's up, Ethan? But I mean, it becomes basically 0. It's a horizontal asymptote. Yeah. What's up, Ethan? So yeah, after this, right, this becomes like 6. So here's what I want to show you, Nick. Do you see how this graph, the amount of stuff there is, like over a certain amount of time, kind of looks like a curve, right? This is what's called an exponential decay. So this looks like something, I think it's like e to the minus RT over lambda. I think this is what this is. I think it's something like this. Yeah, right? Okay. That's what this curve ends up representing. It ends up representing an e to the negative x. And in order to get to that, right, let's say this is the amount, okay? The equation is, I forget, I think it's a is equal to a naught e to the negative RT over lambda. I think that's what it is. In order to get this half-life term, I think this is T1 half. Actually, one sec. Let me just look it up. I don't remember them all the time. Half-life equation. There we go. This is what I want. Sorry, it's not e to the negative x. It's 1 half to the. I mean, you can represent it. One sec. Half-life equation. You can do it with e. This is what I want. This is what I want. Yes. Whatever. Here it is. Okay, cool. Let's pull it in. Yeah, she used a instead of n. That's okay. So this is what it ends up looking like, right? Okay, so it's, sorry, I had my lambdas wrong. It's e to the negative lambda t is what we say. This is it. So we say that she uses a instead of a. That's okay. So that would be a is equal to a naught. So this is the amount you start with. This is the amount you have at a certain time. And then this is e to the negative lambda t, okay? Where do they put like what the equation is for the half-life? It's like half-life. Yeah, they all use like different values. They use lambdas like different values. But then what is T1 half? Where's T1 half? Oh, okay. Actually, I remember how to derive this. I remember how this works. Okay. So if you want to figure out the half-life time, right? You want to figure out the amount of time it takes. Yeah, that's what she shows. Yeah, she uses log. Yeah, okay. Oh, so she's using the 1/2 definition. Okay, that's okay. So sorry. She's using this one. Yeah, this is fine. This is a is equal to a naught, and then she's using 1/2 to the t over T1 half. T1 half. This is the half-life time, okay? In order to solve for T1 half, you have to move this over. So this is a over a naught is equal to 1/2 to the t over T1 half. And if I'm trying to this is a good trick for you guys. If you're ever trying to get something out of an exponent, the trick is always to use logs. And you can use natural logs, regular logs, it doesn't matter. She uses regular logs, but most people use natural log. So if I take the ln of both sides, so this is a over a naught, this is going to be equal to the ln of 1/2 to the t over T1 half. The cool thing about natural logs is anytime I have the natural log of something to an exponent, the exponent can come all the way down. Right here. So for instance, ln of a to the b is the same thing as b ln a. That's the rule. This thing right here, this comes down here. So this comes out front, okay? And so then we get ln of a over a naught is equal to t over t 1/2 times the ln of 1/2. And then you just isolate for t 1/2. So you end up moving this over, flipping it, and then flipping it again. So it's like ln of 1/2 over the ln of a over a naught. And then this is all times t is equal to t 1/2. Yeah. So that's where the natural log comes into play. The natural log comes into play, Nick, because if you're trying to isolate for half-life, you're trying to isolate for this, you have to take a natural log to pull this thing out of an exponent. That's where it comes from. Lots of letters. Yeah, I think the standard way we learn it in physics is this. I think we use this. I think we like using E. And then everything's based on like ln of 2s and stuff. Yeah. Because they end up calling it like E folding lengths and whatnot. Yeah. Hey, they see X and go wild, dude. Uh-oh. Anyways, that's a good question. I like that, Nick. I hope that helps you out a little bit. It's a cool science question. All right, Ethan, what's up? What do you want to say? What's up? And then we're going to do Jamarcus's question. Okay. We got a challenge. We got a challenge question. Uh-oh. These are, for those of you who are watching, these are, so one of the students in our class, in our Discord, his name's Jamarcus. He goes to this Russian school for math or whatnot, and they just end up giving ridiculously high-level equations. Yeah, Zach, you're going to love these, dude. I'm going to need your help on these. Yeah, so he's given these, they're almost like Math Olympiad type questions that end up stumping me a lot, honestly. For those of you who are watching, like, don't worry. This is not covered in a standard math class. It's not covered in high school or, like, even college. They make math, like, deliberately tricky to try to weed out who wants to really figure out the puzzle. But they're fun. I like them. So, a triangle with one angle measuring 40 degrees is cut into 6 triangles by its angle bisectors. Some of these new triangles are right triangles. What could be the measure of the largest angle of the original triangle in degrees? Oh, my God. Wow. The possible measures of the largest angle. Oh, you have a Math Olympiad this Sunday? You're feeling good about it? Oh, awesome. Yeah, how'd you do in the last one, Jamarcus? How'd you do on your Math Olympiad? I got like the top 5%. Nice, dude. That's dope. Dope. Okay, so this one is 40 degrees at least, right? Angle bisectors. That's where we cut the angle in half, I think. Pretty sure. That's this, right? So this is going to be, what, 20 and 20? And then we have some other ones that get cut. So this is going to get cut in half, and then this one's going to get cut in half. Okay, they say they form six. It forms 6 triangles. Where are the 6? Oh, I see. Okay, Okay, I see. I see what they're saying. Yeah. No, that's very good. Something to put on your college apps. Yeah, I put it when I was applying to colleges. I said that I did like Math Olympiads and stuff. It's very cool. Yeah, and personal achievement. Yeah, it's dope. Yeah, we like that.
That's dope.
Self-confidence. It's a thing more y'all need in life is, you're not always going to be great at everything. So what really helped me in life is when I was bad at something, I'd be like, but wait a minute, I'm really great at this. And then you don't feel as bad about being bad at something because you're like, oh, well, I'm actually good at something else. So if you do good in the 10th, then you get invited to high-level national and international teams. Wow. I wonder how the team aspect goes because, wait, are you all allowed to take the exam together? Or is it something where you all take it separately and they just add up the scores of everyone on your team? It's not like you collaborate on it, right? Yeah. But I think in this question, okay, so I think the 6 triangles is like, this is a triangle, and then this is a triangle, this is a triangle, and then this is a triangle, and then this is a triangle. So those are the 6. Some of these new triangles are right triangles. So some of them. So at least one of them has to be a right triangle. Well, if any of them are... here's an interesting thing. Oh, wow. Thanks, Sam. 24 months. Wow. 24 months on the subs, dude. Wow, 2 years. Did you get a special badge? I hope you got a special badge for that. I think I did make a 24-month badge for you. I had to make all these badges. Academic achievements are good. Yes, they are. Yeah, it's good. Well, what it shows to colleges is that you're not just a robot. Like, you go out and participate and interact with people. And especially if you're on like a math Olympiad type something, it's there's some cool team aspects to it. It's great for people, like me. I was never the best at sports. I was honestly pretty terrible. I tried to be. I tried to do everything. I was the only boy in my family. I have 5 sisters, and so my dad, I think, was really trying to get me to do sports. But I was like, Dad, I'm no good at sports. So I ended up being good at math. So that's what I did. But yeah, it is like a sport. It's cool. Academic achievements are cool. So here's an interesting thing. If one of these ends up being a right angle, the other one has to be as well. Because these triangles that are formed get formed in like pairs, where this is going to be a straight line. So these 2 angles have to be supplementary to each other. What's up, Nick? You're doing a lower level math Olympiad type with Ravi. Oh, that's cool. Which one's Ravi? Who's Ravi in our Discord? Forget. Okay, let me think. What are the rules for this being 90 degrees? This is the problem with geometry. I have to remember all the special rules that happen with things.
You see how geometry is just a little confusing for me?
It's not confusing. You have to have like a big toolbox. Like there are a lot of weird properties and rules. Like when we were working yesterday, remember when we did all the triangles and stuff like this? Oh, do you remember this question?
Yeah.
Yeah.
It's ugly.
There's a lot of special rules that you have to remember, right? Isosceles triangles, 2 same sides, 2 same angles. And then whatever the angle is here is half of the angle that's like here or something. There's a bunch of rules. I'm trying to remember what the one is for triangles though, with angle bisectors. So, okay, when in doubt. What's up, Ethan?
I actually did my physics exam today.
Nice. How'd it go, dude? How'd it go? What's up, Undecided?
I'm a little worried for my result.
Okay.
Like I said before, I needed a 93, so my chances of getting an A are pretty slim.
It's okay. I mean, getting a B is fine, all right? That's okay, dude. Yeah, don't worry.
And literally no one has an A in my class for physics.
Well, if no one has an A, then your class is gonna get curved. That's what happens. Your teacher's not good.
No. Some teachers will do that. He won't. I know he won't.
Oh, all teachers should curve, dude. Fluid mechanics is pretty cool. Yeah, fluid mechanics is cool. I did a lot of fluid mechanics.
Whatever. Yeah, I want to ask questions about only math now. That's the only thing that's worrying me.
Okay, well then yeah, we'll ask math questions. I'm trying to figure out.
I really don't know. I really don't know if I can answer a math question. It's based on a topic. Can I tell you what it is?
Yes, when it's your turn. Tell me when it's your turn. I'll do it. Let me do Jamarcus's question real quick.
When is it my turn?
After everyone else who's submitted questions. That's how it works. Yes, the try hard. Yeah. Sorry, I'm still a little sick, honestly. What? How do I figure out it's 90 degrees? Oh, okay. Whoa. Okay. Wait a minute. This property holds. That's cool. Proportions. CD over CA is DB over BA. Is that so? Wait, what? CD over CA. So small side to the hypotenuse is... How do I know that's the smaller side? Excuse me? Does that really work? Hmm. Okay, well the Pythagorean theorem we know that holds if it's a right angle, if it's a right triangle. I know that's true. Angle bisectors. Angle bisectors creating triangles inside 90 degrees. Maybe something come up. We'll just see. Yes, this is if it's like a centroid. I know this one. Mm-mm. Mm-mm, 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 mm-mm. Okay, ooh, let's see this. We love Quora. Quora has some great things. Ugh. The angle between the internal bisectors of two angles of a triangle is 120. What is this? Okay. This is interesting. Oh, is this kind of like the circle theorem where the angle is half of what the outer one is? I feel like it kind of is. But why is that? Oh, but these cut these in half. Okay. Okay. All right, let's try to like just label some stuff. Maybe we'll get to it. Maybe we'll get to it. If anyone else in the chat has an idea, please let me know. I could use it probably. Okay, if this is 20. Okay, let's call this A. I'm gonna call this A. Right, I'm gonna call this B. I'm gonna call this C. All right. I know that this is going to be B over 2. This is going to be B over 2. Oh, the intersection point of all angle bisectors forms the incenter. Oh, is that the one where this is the radius, Zach? Is that correct? I think that's what you're talking about. Almost. Oh, almost. Okay. Let me look it up. I'll look up what the incenter is. Oh, it's not though. Hmm. Yeah, does that help me though? I don't know if that helps. Because I think... Here, let me copy this image real quick. Yeah, the circle part's correct, yeah. Yeah. Because I think what's happening here, Zach, is they're asking about... So the 6 triangles that get formed. They're talking about, for instance, this triangle and this triangle. And then this triangle and then this triangle and then this triangle and then this triangle. And they're saying one of them has to at least... Well, and it can't just be one. 2 of them, right? Will have to at least be 90... 2 of them have to at least have 90-degree angles. Right? Because if this one has a 90 degree, then this one will have a 90 degree. However, at least one of the bisectors aligns with the perpendicular bisector of the side. Does it? It doesn't look like it does here. Oh, the perpendicular bisector. Well, perpendicular bisector would be this, right? Is that what we're saying? That's right, where it bisects this and it does this. Oh, yeah, no, I see what you're saying. Yes. Yes, no, you're right. Chat is hard. Yeah, chat is hard. No, you're right, Zach. Yeah. Right, okay. Yeah, one of them will have to. I like that. Okay, yeah, okay, let's do that. Let's take the case that one of them has to be. Um, okay, let's say that like at least two right triangles exist, right? I didn't draw all my angles. One sec. Go away. Okay. So if let's say one of them has to at least be a 90. So say this one has to be. Let's call this one here equal to 90, right? So that means this is 90, and this is 90, which would mean that this side here is equal to this side. Yeah. Right. Okay. What does that enforce then about this? AFK, you're back. You're good. You're good. I'll try and figure it out. Okay. Well, we know this angle, right? Has to be equal to this angle. Okay, cool. And then we already know that this is 40 and this is 90, right? 40, 90 is 130. So this has to be 50. This has to be 50. Okay, cool. All right, so that's our first one. I think that's going to be the largest angle. Because then if this is 100, Jamarcus, right? Then 100 and 140, this would also have to be 40, right? Does that make sense, Jamarcus, right? If this is 40, right? And then I'm having this be a perpendicular bisector, right? And I know this is 90, then this small part here has to be 50. Because 50, 40, 90 has to be 180. Okay. And then, yeah, that's the biggest angle. Okay, so we got one of them. The measure of the possible measures is 100 degrees at least. Right? Because they tell us one of them is 40, right? One of them is 40. Okay, one of them is 40. All right. I forgot to scroll in Discord chat. Oh, my bad. Sorry. Oh, I did. Yeah, you're bad. Sorry. Yeah, I had it. Angle bisectors are also medians and heights in isosceles triangles. Heights form 90-degree angles. Oh, yeah, my bad. Okay. But how do you know that it's a bisector of the side and not just an altitude? Well, no. 100 is only one of them. There's a couple answers, right? Don't we have to? Oh, leave unused. Yeah. No. I think there are more ones. I think there are more than 100. I think 100 is not the only one. Or maybe it is. Maybe it is the only one. I think it comes down to maybe the question, how the question's asking. Sorry, let me see. Triangle with one angle is cut into 6 triangles by its angle bisectors. Some of these new triangles are right triangles, which could be the measure of the largest angle of the original triangle in degrees. I think 100 is correct. Um, it's asking for the largest side. There can't be multiple. Well, there could be if it's like an obtuse triangle. Yeah, I think Jamarcus is what it's saying is, for instance, you could have like a 40 and a 100 and a 40, or maybe we could have like a 40 and like an 80 and a 60. In this case, these would be like two times. These would be two different cases for what the largest angle in the triangle is. It's for different types of triangle. Well, because a lot of times, right? You know, if I have a triangle that does something like this has the equivalent properties to a triangle that does, I don't know, something like this. Doesn't make sense to have the largest. It's the largest possible angle for each triangle, but I think there are multiple types of triangles that this can happen with. Right? I think the original triangle can either be obtuse or acute. I mean, let's say our original triangle was a right triangle. Let's just do that. Let's just have fun with that, right? Let's say this is 40, this is 90, right? And then let's say this is 30. 50. But why do they have multiple answer points in their Jamarcus? That's what I'm getting at. Why would they tell me that? I don't know. Do any of these like work? Would any of these create? Yeah, I guess. Oh, I see. In order for the angle bisector to be a median, is that what you're saying? Or an altitude? Sorry, is it median or altitude? It is a weird question. I agree with that. I don't. No, it's not a median. We want an altitude. Yeah, this is what they're asking. I think this is what they're asking. So this is what we're saying. We need this to happen, where at least one of these is, or all three of these have to be angle bisectors, but only one of these needs to be like a right angle. Angle bisectors are medians and altitudes as well in an isosceles triangle. Yes, but can an angle bisector be an altitude not in an isosceles triangle? Oh wait, can an angle bisector be an altitude in a non-isosceles triangle? I think that's what we're getting at. Oh, okay. Well, I guess this is maybe a rule. I'm just wondering if it's like if A then B or if B then A. Dr. Gold cheating using Google? No, it's okay. I mean, this is just a tool. How do you prove that if the median, altitude, and angle bisector from one vertex are equal, then prove that it is an isosceles triangle? So yeah, I agree with this. So if something is isosceles, the median, the bisector, and the altitude are the same line. But I want to know if I can have it without the median being the same. But then why do we include the median part? Fucking triangles, dude. Yeah, maybe this question may be like written wrong, honestly. Like maybe are they talking about these 6 triangles? 1, 2, 3, 4, 5, 6. Are these the 6 triangles they're talking about? I thought they were talking about this one and this one. Oh, it is the 6 small ones. Okay, wait a minute. Let me get my other picture. What was that other picture that yeah, this is what I want. I want this image. Okay, let's look at this image. Okay. So sorry, we're talking about these 6 then, right? This 1, 2, 3, 4, 5, 6. These 6. It's the 6 small pieces. Okay. Cool. All right. Let's assume that one of them is 90, right? Let's assume that this is 90 and this is 90. Let's just assume it, okay? Let's see what restrictions that would put on other things. So and then let's say this one is 40. Yeah, then this one, right? This one has to be wait, sorry. 90 and 40 is 130. Yeah, this has to be 50. Right? 90, 40, 130, 50. That's 100 degrees. That's 40. Okay, cool. Whatever. Same thing happens if this is 40, right? Right, if this is 40, 40, 90. Okay. Here's the other option. Let's make this one equal to 40. Okay? So now that this is 20, Jamarcus, now 20, 90, this one ends up being 110. Or sorry, this ends up being 70. Right? And for 110, so this also ends up being 70. Okay. Okay, so here's what you can have, right? You can either have a 70, 70, 40, or a 40, 40, 100, I believe, right? So these are your 2 answers. You can either have 70 be the biggest or 100 be the biggest, right? I think that's how you do that one. Is that not right? 100, 70? You tried both 70 and 100? Both wrong? Well, I don't understand what the question's asking then. Oh, okay. Well, okay, whatever. Russia's wrong. Show me the answer when it comes up. Or they never show you the answer for these? So mean. Why do they give you questions but they don't show you the answers? Like, fuck that. The rest they leave you wondering. Well, this is leaving me like confused and upset. So I don't know. The other question you put is even worse. Okay, well maybe let me do someone else's questions real quick, and then we'll get to that one. Yeah, I'll have a look at it afterwards. I don't want to look at it right now. I'm already hurt by this one. This one hurt me. But I'll save you credit. Okay. All right. Let's see. Who else we got? Cuber. Oh, but Cuber's not here for another 20 minutes, I think. So,
there is so me.
There is you, Ethan, for sure. And then I guess I did help out Nick already with something, but wait here, let's do his because he hasn't asked this one in a bit. And then I'll do you, Ethan. I got you. All right, Nick, what's up? Nick says I'm here. Yo. Okay, let's see. Recognize, analyze, and describe real-world chemistry events. Okay. Keep a journal for 3 days. During this time, recording the following events you observe in your daily routine. What if your daily routine is literally just waking up, playing Fortnite, and then going back to bed? Like, what's the chemistry you're gonna like observe? Okay. Wow. Minimum of 30 entries, events clearly identified and described. Descriptions written your own. Dude, what? How is this part of your chemistry class? What is this, dog? Excuse me?
This is a project.
Okay.
Second one.
Any event that illustrates any of the gas laws in your notes, describe the event and concepts from the course. Okay, so, wow, you have to come up with 30 things of, like, chemistry happening in your everyday life?
Yeah.
You want me to just, like, give you some ideas? I can give you some ideas.
Sure.
Okay. So let's say, like, I don't know. Let's say you went and you touched grass. All right? That's good. We like to touch grass. And you sweat. Let's say you sweat a little bit, okay? Say you went outside, you ran a little bit, and you sweat. Okay, this is cool. This does demonstrate a chemistry concept. What chemistry concept does this demonstrate?
Mitochondria.
No! No, dog.
I don't know.
Do you know why you sweat?
No.
No? Okay.
I mean, I do, but I forgot.
What? You can't think of it?
Yeah.
Let me show you. Sebum? What? Sebum is a thing? I didn't know that. Now they're getting a little too involved with the sweat. Okay, whatever. Oh, I guess, okay, this is actually kind of cool. Biology is fun sometimes. There's a little bit of fun. I mean, there's more like, I think of it more of like a physics point of view, but these are all the little things underneath your...
I did my first project, and it was about how you're supposed to pick a element and pretend that you're the element.
Pretend you're the element? Which element did you pick? Tell me did you pick gold?
Uranium.
Uranium? What, are you like toxic to people, dog?
I knew exactly if I told you, you would have said gold.
Yeah, you should have said gold, dude. Yeah, gold be the best element to be, bro. What?
Yeah, make everybody rich.
Anyways, okay. So sweat, right? You know, like, well, how do you start sweating? Why do you sweat usually? Why? Like, are you too hot? You're too cold? Why do you start sweating? Because you're too hot, right? Yes, good. Right, yeah. Usually you're exercising or like running around or something, right? You start sweating, or if it's hot outside, right? Yeah, okay.
Mm-hmm.
Okay, and you sweat in order to do what? To feel cooler or to feel hotter?
Cooler?
Yeah, feel cooler. Yeah, good. Yeah. So sweat is your body's way of trying to like get colder. It's trying to remove heat from your body, okay? And what that does is, I guess there's a bunch of little glands here and whatnot, sweat secreting cells, whatever. But they basically put water on top of your skin, okay? And then what happens is this water will evaporate into gas, into the air, all right? But you know that in order for evaporation to happen, you need to give energy to a liquid, right? This is what we call is like HVAP. They call this enthalpy of vaporization. Yeah. or heat of vaporization, I think is what it's called technically. So the reason why you sweat is in order to take out some of the heat from your body to evaporate water. That's what sweating is, and that's a gas change, right? It's called a physical change technically. It's not a chemical change, but it is something that happens in chemistry. So this would be an example of a physical change.
Mm-hmm.
This is actually a very other cool thing. Do you know about humidity, right? When there's like a lot of water in the air, you know about humidity, right?
Mm-hmm.
Does it feel worse to exercise in high humidity or in low humidity?
High.
High. Why do you think it feels worse to exercise in high humidity? I'd be concerned too. Well, let's say it's the same temperature. Let's say it's 90 degrees in Arizona, which is dry as fuck, or it's 90 degrees in Florida, which is super humid, right? Besides it being Florida, you don't want to work out in Florida in the humidity. And the reason for that is when it's humid outside, there's already a lot of water in the air. That's what humidity means. It's like the amount of moisture that's in the air, okay?
Mm-hmm.
So if there's already a lot of moisture in the air, the moisture on your body doesn't want to join the moisture in the air because there's too much there already. So this is also kind of like this is a gas law type thing. It's kind of like Le Chatelier's principle, but for physical changes. So that's why, and also humidity. So like water in the air holds in the temperature a lot more. This is why, for instance, if you go to a sauna, right? The wet sauna will get you warmer quicker because it conducts heat a lot better. Yeah. So this is another cool thing. So you can't sweat, honestly, in high humidity climates, or you can't sweat as well because your body, there's already too much moisture in the air that the sweat on your body doesn't want to join it. So that's another cool thing. Yeah. Okay. Cool. So sweat. That's an example of you touch grass and you sweat. Yeah. I don't know. Okay. Let's think of like another. I'll give you a couple of them. I'll give you a couple. Then I'll go help Ethan with this stuff. Another chemical change. Okay. Let's say. Trying to think like what you do in your house. Okay, you can say like you turn on the stove. You turn on the stove, right? Okay. And let's say it's a gas stove, right? That's an example of a chemical change, right? Because what you're doing is you're igniting propane. That's right, what's happening. Okay. And that's like, I think that's like C6H10O6. What is propane?
And then I had to find
Here it is.
Site my where I find all this information.
No, I mean just Google it and then just write down the websites. We're not.
Yeah.
I'm just gonna give you the topics so that you can go find them. I tune into your stream and I see touch grass and you sweat. Fortunately, I've been online all day. I went for a walk today. I had to go. My car needed a safety recall, and so I had to walk back from the dealership. So yeah, I walked like 2 miles today. But yeah, this is another example of a chemical change that happens in your life, right? This is igniting propane. This is a good equation for it. Nice. Yeah. Okay. Let's see. You could also like driving a car. You've done that, Doc? Okay, cool. That's cool, Monkey. Appreciate that. I'm glad you've touched grass or you've turned on the stove. Both are good things to do. Both great. Okay. Let me think of another one. Another chemical change. I always ever think of it just burning things. Combustion of this, right? Because you can also, drive a car. Driving a car. That's a chemical change. And that's the combustion of gasoline. Okay. So again, you can just look these up, Nick. You can just say combustion of gasoline equation, gasoline. And yeah, cool. There we go. There's a gasoline combustion equation, whatever. Wait, why'd they put a D in there? I don't know. No, I just want the one with the actual thing in it. No, dude, I just want the... Yes, there we go. This is what I want. This is it. There you go. And the chemical equation. Yeah, it's good. Oh, you've done the chemical equations, Monkey. That's cool. Yeah, there you go. That's like the combustion of gasoline. Let's give you like 2 more. Oh, you know what's another good one? Let's say you go put ice in your drink. This is a good one. Like to cool down your drink, right?
Oh.
This is a physical change, right? Which we would call melting, right? That's another one. I can't believe you have to come up with 30 of these. Like, what?
Bro.
30? Like, I can't even think of like 30 things I did today.
I can email the school and like ask questions about whatever homework I want. I asked and she's like, yeah, do 30. I'm like, okay, thanks, bro.
Yeah, okay, thanks. Big help.
Yeah, right? She gave me one example though.
She gave you one example?
Yeah.
Which one did she give
Thank
you?
God.
Which example did she give you?
Let me see.
Double replacement, single replacement, acid base. Yeah, I wonder. Trying to think if there's any acid base reactions that happen in like regular life that's like toothpaste or something.
She said, I picked up my bike and noticed it had rust on the frame because I left it outside overnight.
Rust, yes, oxidation. That's a good one. Yeah, oxidation's great.
Reaction called oxidation, also known as oxidation, reduction, redox.
Yeah, redox.
Reaction.
Yeah, redox reactions are good. What's wrong with your school, Monkey, right now? Like, your old school is cool. What's wrong with your current school? Here it's just boring? Well, here, let's make it interesting. You can always do interesting stuff here.
Now?
One sec, I got a last one for Nick. I got to figure out one more for him.
I thought of like maybe like milk spoiling or something.
Milk spoiling. Yeah, that's a good one. That is a good one.
It's turning into cheese.
I believe that's a chemical change. Yes, because there's a reaction with like yeast and stuff. Yeah. That's a good one. Yeah, you can put the milk spoiling.
And like maybe banana or something from like, I guess as well oxidation, no? I don't know.
Bananas don't really oxidize, I don't think. No, that's more like rust and stuff, yeah.
Or maybe apples. That's different, yeah. There's iron in it or whatever.
What is an acid base? Yeah, acid base reaction is like when you have something acidic and something basic and you mix them together and they neutralize each other. An example of that would be like lemon juice and bleach. Those are two opposites. Lemon juice is an acid, bleach is a base. Soil. Yeah, okay, here's a good one. Yeah, good job, Monkey. You actually you jogged my memory. Let's say you go out and you fertilize your lawn. Have you ever heard of this like fertilizer?
Yeah.
Yeah, so fertilizer is I think it's usually like sulfate or something, or phosphates. Is that what it is? It's also extremely flammable. That's why people like build bombs. But
I was about to say.
Yeah, fertilizer, chemistry. Yeah, because fertilizer is used to stabilize the pH of the soil, is what it is. So here are the, let's see, and make it fertile is what they say. Like make it able to have plants growing it and shit. Yeah, a lot of nitrogen. Yeah, that's right. Phosphorus and potassium. Yes. Okay, acidic soils have better nutrient availability. Okay, so cool. So yeah, it makes the soil more acidic. So yeah, you can talk about this. Here, let's paste this image in. This is a good one. It's a good one as well. That's a chemistry thing. Let's say you fertilize your lawn. Yeah. Wants to paste in. Yeah. So you could talk about this is a chemical reaction, and you're making soil more acidic. There we go. Okay. Good job, Nick. Did that help you out? Get you started at least?
Yeah. Thank
Okay,
you
cool.
so much.
You're welcome.
After this, I'm gonna website that already has like 30 entries.
You're right, dude.
Bro,
Nice.
30 entries is too much, man.
Yeah, that's a lot. Honestly, this is kind of a...
15 at least, bro. Like,
Dude, she's like, yeah, what? Keep a journal, minimum of 30 entries.
and have fun doing this for 3 days.
Yeah, what?
Thank you.
Did you see the thing where Mr. Beast apparently kept someone locked in a grocery store for like 10 days or 15 days or something? You guys seen that video?
Bro,
Dude, he does the funniest
no,
challenges. I
don't-
like
don't
him.
watch his videos. 'Cause I don't know.
Why? Why don't you like them? I think they're pretty cool.
I don't know. The more views he has, the more money he has. I don't know.
Oh, well, yeah, what's wrong with him having money? He gives it all away. That's okay. He doesn't give it to you? Well, not yet. Was it 50? Monkey, was it 50 days? Yeah, he was trying to go to 500,000 or something. It's something like he had to sell $10,000 worth of stuff like every day. And then he started missing his kids. It gets like kind of deep. He put himself in complete isolation for 7 days. They have this. It's actually a cool thing. I actually met someone last night that does these. They're called Vipassana meditation retreats. Here, let's see. California. And what you do is they're 10 days long. And you go to these places and you don't speak to anyone for 10 days. You have to just be totally quiet for 10 days. Yes.
Yeah.
And then you also like kind of fast and whatnot. I had a friend do one.
Like silent retreat or something?
Yeah, it's a silent retreat. Yeah, here we go. Yeah. It's apparently a cool place. But yeah, 10 days. Wow.
Would you do it?
I wanted to, honestly, and I had the option to do it in grad school, and honestly, I should have done it because there's not many other points in your life where you can just disconnect for 10 days. Like, if I just stopped doing everything I was doing for 10 days, people would start getting worried. I mean, people would start failing classes. Like, people rely on me for things. I can't just, like, detach for 10 days. That's a lot.
Right now.
Like, you have no cell phone, no talking, no anything. It's super crazy. Yeah. I should have done it during grad school, because grad school, you can disappear for 10 days and no one really cares where you're at. I did that with my advisor. I went to Thailand for like a month. I didn't tell my advisor I was going to Thailand. And then after he's like sending me emails, he's like, hey, could you like come in for a group meeting or something? Or like, how's it going? Like, how's your stuff? And I was like, oh, yeah, no, I'm cool. I'll be back next week. Yeah. And then I told him, I was like, yeah. Who else can I manipulate to do my homework for me for free while also paying me? Yeah. Exactly. Jamarcus, do you know about the other streams as well? I feel like you'd have a fun time asking these questions. Like, if I can't solve them, because again, my math tops out. I'm not super high level on some of these things. But Zach, who is E to the 2I pi, he's very, very smart, and I think has a lot of good intuition with trying to solve some of these trickier questions. He has a good stream. Do you know his stream? Here, I'll send it to you. I need to get their schedules and whatnot and just put them in the server. That's what I need to do, so that y'all get a notification when they go live as well. So yeah, this guy is really cool, Zach. He does a lot of cool stuff. And then here, I'll paste them in here. And then this one, Don Does Math. He does a similar stream where he asks. Yeah, just follow them and just see if they're online. Yeah, that's what I do. Like, I just follow them, and you get the notification here at the top left when people are online. But Don, he claims, what does he say? There's no problem I can't not solve. What does that mean, Don? There's no problem I can't not solve. Too many negatives. But he gets some pretty tricky questions here, pretty high level stuff. So I'm sure he would be entertained, man. If there's a question that I can't. So for instance, you should give him. You should hop on the stream with him if you can, and give him the question that we tried to do. I'm just curious. Yeah, and I'll raid his channel after this, anyways. Yeah, I'll raid his channel. Yeah, I'm trying to do that. I'm trying to raid more of the math stream. I forgot to yesterday because I was in such like a rush. But yes, I'm trying to raid more of the other math streamers. They're cool. Cuber, what's up? Yeah, let me do yours real quick. Yeah, sorry. Yeah, then Ethan, I'll do yours, Ethan. But I worked with you almost the whole time yesterday, Ethan. So let me make sure I have time to work with the other students. Where is your
Good,
question? Yeah.
Francis.
Okay, here we go. Cuber. Because we did like all 9 parts of your question last time, Ethan, didn't we? We spent like a solid hour almost on that.
Well, like 30 minutes, not an hour.
We spent a while. I feel like it was a while. Why can't I open this picture, man? What's that? Copy image. There you go. Now it's uploading. Okay, cool. And then, oh, I like this. What's this number of the week, dude? What's going on here? Okay, cool. Number of the week. Wait, do you seriously get this in your class, Cuber? Is this what they give to you? They give you this? They give you like a number? This is like, I like the aesthetics on this. This is pretty cool designed. Okay. Yeah, we do a number of the week every week. Okay. Okay, well you got the first part right. Okay. What's this part? What's the absolute value of it? What's that? I don't. Okay. Do you know what absolute value is? It's okay. I can teach you what absolute value is. Okay. Absolute value is whenever you have a number, taking the absolute value of it makes it positive. Make sure it's not negative. So, for instance, the absolute value of -5 is +5. But also, for instance, the absolute value of +3, that's just +3. So, all it does is take negative numbers and make them positive. No. So this week's number is -10, right? So what's the absolute value of -10? 10. Yeah, good. Okay, cool. Awesome. Here, let me throw this back on. Okay, cool. Okay, good. And then write the first 5 multiples. Okay, not factors, multiples. Yeah, you're welcome, dude. Yeah, I can make you speaker. Yeah, sorry. Yeah, here. What's up, Cuber?
Hello, can you hear me?
Yeah, I can hear you, Cuber. You're good.
Okay.
Okay. So
Yeah, is there like multiples, like negative numbers, or?
no. So multiples, they mean like if you were to multiply this by 1, by 2, by 3, by 4, by 5. I don't think it's the factors. Yeah. If they ask for the first 5 factors, then what Monkey's saying is correct. That would be 1, 2, 5, and 10. Yeah, those are factors. Multiples is like multiples of -10. So for instance, what's -10 times 2?
-20,
Good. And then times 3?
and -30.
Good. There you go. -40, -50, right? Yeah. So I mean,
Wait, so
technically,
is -10 a multiple, or?
I mean, it is because it's multiplied by 1, right? I don't know. It depends on your teacher's definition of what a multiple is. Like what? what is a multiple? I don't know. Okay, yeah, they count the 1. They count the times 1.
All right.
Okay, cool. Is -10 an integer? That's a good question. What do you think?
I don't know what an integer is.
Okay. Well, here, let's go again. Google's the best. So, what is an integer? An integer is a whole number that is either negative, non-negative, or positive, or 0. So, wait, what's the difference? Oh, okay. So, this is too funny. So, negative, right? Negative numbers are these, like -1, -2, -3, -4, -5, right? Those
Yeah.
are negative numbers. Non-negative means it's not negative. So, technically, that's all the positive numbers, right? 6, 7, 8, 9, and 0. 0 is not negative, and it's also not positive. 0 is like a weirdo. Okay.
Okay.
Yeah. So, I mean, this is another graph that they kind of show here. You see how like negative numbers on the left side of the number line, Positive number is on the right side of the 0 on the number line, and then 0 is not positive or not negative. Okay.
Yeah.
Okay, good. All right. So is negative 10 an integer? Or sorry, integer just means it's a whole number.
Yeah.
Yeah, good. It's if this was, for instance, like negative 10.5, would that be an integer?
No.
No, good, because it has a decimal, right? It has a fraction part to it. Okay. All right, so then they say have it. So how do I cut negative 10 in half?
Would it be -5?
Good, yeah. You're just dividing it by 2, right? Or the other way to say to have it is to multiply by 1/2, right?
Yeah.
All right.
So 25% would be
yeah,
0.25 minus 0.25.
so it would be 0.25 times negative 10 is what it would be.
So minus 2.5. Or
Yeah, good. Yeah, whenever you're saying find, some percentage of something, you just take that number, the percent, and you move the decimal to the left 2 places. Do you know that? Do you know that trick?
yeah,
Here,
I didn't know how it worked with the negative numbers.
Oh, you just makes it negative. That's it. So, for instance, if I said find 30% of 12, do you know how to do this? Or let's say 40%.
It'd be
40. Let's say 40%.
12% of 30, right? Or,
Oh, that's interesting. Yeah, that also works. You could also say
I
this
know.
is also the same thing as 12% of 40. You're right. That is, but this is hard. Like we don't want to do this. That's tricky.
yeah, I don't know how to do it.
Okay, so Monkey has a good way to do it. So one way to do is to write this in terms of a fraction. So you could write this 40% is the same thing as 40 over 100. Does that make sense? 40% is the same thing as 40 over
Yeah.
100. And that must equal some amount x over 12. This is another way they sometimes do it. And then you have to solve this kind of using like algebra. I think what they would want me to make this like a nice number. Let's say I said 40% of 10, okay? This is kind of usually what they do. Okay? And then what all you're doing is you're saying, "Oh, okay, how did I get from 10 to 100?" Do you see how I multiplied by 10? So this would have
So it'd be 4?
it would be 4. Exactly. That's one way to do it. But that only works with nice numbers. It only works when you have nice percentages and nice things like
it's hard
this.
with 12, right?
It is. Right. So yeah, 40% of 12. Again, you could do it this way. You could do the 40 over 100 is equal to x over 12. You could cross multiply both sides, right? So then you get 100x is equal to 480.
Yeah.
And then you got to divide by 100. You got to divide by 100. X is equal to. So here's the cool thing when this happens, Cuber, is you can get rid of the 0, and then it's 48 over 10, which is the same thing as 4.8. Because you can get rid of this and then a decimal moves over.
Mm.
Yeah, that's another, but whatever. Again, this is if you have to do it by hand. The other way to do is just take this, you move the decimal 2 places to the left. So that's 0.4. And then you multiply it by this times 12. Okay?
Okay.
This may look kind of hard, right? 0.4 times 12. But a way I like to do this to make this easy is I pretend...
Oh, wait, couldn't you...
Yeah?
Couldn't you do 4 times 12?
Good.
Then move it over?
4 times 12 is 48. Great. Good. And then you move it over. Yeah. Because that's where it was.
Yeah.
4.8. Yeah, good. Good. That's how you do percentages. Okay, cool. Let's go back to the rest of the question. Square it. Ooh, okay. Yeah, what does it mean to square something?
Multiply by itself.
Multiply it by itself. So negative 10 times negative 10 is what?
Negative 100.
It's a positive 100. Yeah, Monkey's right. It's positive 100.
Oh, okay.
It's positive 100. Because what's happening here, is you're multiplying.
They cancel each other. Yeah.
Good, good. If you're doing negative 10 times negative 10, two negatives multiplied by each other cancel each other out. So you just get 100. Monkey was asking, can you square root negative numbers? Not easily. You can use what are called imaginary numbers, which you're not into yet. It's okay. So, for instance, if I had like the square root of negative 25, this would be called negative 5 times I. The imaginary number is what there is. Imaginary numbers, very cool. Yes. I just divide by 10 and then multiply by 4 or multiply by 0.4. Yeah. Oh, good. I thought it was imaginary. Yeah, I is imaginary. I is defined as the square root of negative 1. So what you end up doing is you break this up into like the square root of 25 times the square root of negative 1. And then this right here is I. And the square root of 25 is just 5. So that's why it becomes 5I. That's where that comes from. Okay. Triplet. What does it mean to triplet?
Multiply it times 3.
Good. So what's that become?
So negative 30.
Good. All right, cool. You got this one right. People sometimes get this one wrong here, Cuber, right? Because this looks like a bigger number, right? 10 looks bigger than 7.
Yeah.
But there's a negative on
It's
it.
negative. So
Negative, so it's actually smaller. Yeah, good. And then use 4 number sentences that equal all 4 operations. 0 minus 10, good. 0 plus... use, right? 4 number sentences. Okay, don't do this. Don't do 0 divided by 0. You can't do that. It's not good.
you can't.
No, 0 divided by 0 is
wait.
really bad. No.
Isn't it 1? Wait.
No, 0 divided by 0 is undefined. It's not a thing.
Oh, okay.
Yeah, just don't divide by 0. Your teacher will see that and like freak out. She'll be like, okay, here, let's help you out with this part. Yeah. Okay. I agree with this one. This one's okay. I like the 0 minus 10 is equal to negative 10. Okay. They just want you to have two numbers add up to negative 10, right? So, one way to do this, right? Let's think about our number line, right? Let's say this is like negative 10, right? Let's say this is like negative 15, right? How could I get from negative 15 to negative 10?
Negative
Wait, so
15 plus 5.
Good. Yes. See how this difference is 5 and we're going to the right? Yes. So I would say negative 15 plus 5 is equal to negative 10. I think that's a better way to do it.
Okay.
And then they want you to multiply. Okay. So I want to know what two numbers multiplied by each other get me negative 10. How would I
4 and 2.5?
4 and 2.5, but
4 minus 2.5?
yes, good. 4 times negative 2.5. Yes, that would also equal to negative 10. Good. All right, what about division? What's up, EtherPie?
For division. One divided by negative 10?
That would be 1/10.
Or no?
No. So we want a bigger number divided by a smaller number to get down to 10, right?
Negative 10 divided by 1.
Good.
Yes.
Technically, that works, yes. Negative 10 divided by 1 is equal to negative 10. You could also do like negative 20 divided by 2. This would also be equal to negative 10, right? Does that make
Okay.
sense? Yeah?
Yeah.
Cool. All right, nice. And let's see, you had one other one you questioned with. Did we figure out? Yeah, one sec. Let me show you the 2i what I had. Okay, so here's my. I think we have a question, Zach, with honestly just what even the question is asking. So where did we have it? Where did I put it, Jamarcus? Is it here? Yeah. So they say a triangle with one angle measuring 40 degrees is cut into 6 with angle bisectors. Some of these new triangles are right triangles, right? So I think what we came up with was wait, it wasn't here. Where did I put it? No. I had a picture of it somewhere. God damn it. Here? Oh, here it was. Here it was. This is where we found it. Okay. Okay. So we look here, Zach, right? I think what they're saying is we have angle bisectors, right? Which is going to split it into 1, 2, 3, 4, 5, 6 triangles. Yeah, exactly. Right, yeah. So and we know one of them is 40, right? So I made the case of, okay, let's say that this one is the 40, right? And also that one creates one of these to be a right triangle, right? Then in order for that to happen, right, this would be 20. So this part right here would have to be 70, right? Like this whole thing. If this is 90, this is 20, this is 70. So then this would also have to be 70. So I was like, okay, cool. So in that case, the biggest one is 70. And then the other case I could have, right, is I could have this be the 40, but I could have this be the 90 degree, for instance, right? Okay. Let me think. What was my thinking behind this one? Oh, okay. Right, okay, so that makes this equal to 90, right? So then I have a 40 here, a 90 here, so then this angle here must be 50, so then the whole angle must be 100. So then that's a 100, it's a 40, 40, 100. So I think the answer was like 100 degrees or 70 degrees. I feel like that's the only ones you can have. Because those are the two cases. You either have the 40 degree angle also being the 90 degree bisector, or you have it the 40 degree angle not having the 90 degree bisector. I can't see any other cases. Maybe they're also talking about these angles though. Maybe one of these could be 90. Is that true, Zach? Could I have like one of these be 90? Like within the intersection points? I don't think there can be two right angles, right? Because if this one's a right angle and this one's a right angle, and let's say this is also a right angle and this is a right angle, or even all three, I don't think you can. Not with one of these being 40, right? Because if this is 40, right, and this is 90, that means this has to be 50, right? No, sorry. It has to be 70. Right? Because then this would be 20. But then if this is a 90, right? That doesn't work. You can't have 35 and 40 and 90. That doesn't work. Yeah, I think it forces an equilateral triangle for sure. Yeah. My only other, because Jamarcus put in for the answers here. He put in 100 and he put in I think it was 70 degrees, but both of these were wrong. Apparently. So my only other consideration is that maybe something here you could have a 90 degree angle. I don't know how. What about 2? Well, I think we just showed with 2, right? So, well, there's always going to be at least 2, right? Because anytime I make a 90 degree with one of these, I have to make a 90 degree with the other triangle, right? 2 out of the 3? Are you talking about like just doing the, yeah. Oh, I mean 2 bisectors. Yeah, I mean, yeah. I don't think it's possible with 2 bisectors and a 40 degree. It's not. Because, yeah, look, if I made, right, these ones, right, I get the same issue, right? This, maybe we call this one like 40. Oh, Jamarcus says he's an idiot. Okay. What's up? Why are you an idiot? Oh, you put them in wrong? You put them in but separately. Okay. Let's see. Well, okay. So is our answer correct? Oh, there we go. And it was right. Okay, cool. Thank God. It's okay, Jamarcus. Yeah, let's go. Okay, yeah. Yeah, you have to put both of them in, Jamarcus. Yeah, otherwise it gets mad at you. Okay, so it was 100, it was 70. Okay, cool. Crisis averted. All right, Cuber, let me help you with your last one, and then Ethan, I'll help you with yours.
Can you please stop stalling this already? You're really getting.
Well,
You're really just trying to.
Ethan, I'm not trying to stall. I'm just busy. Believe me, I'm not trying to stall anything.
You really expect me to believe that? You are literally doing all the questions so that you don't do mine. That's what you're doing.
Because I did all of your questions last stream, Ethan.
I asked just one question. How?
But it was like a 9-part question.
It was 6 parts.
Okay, whatever. All right, Ethan. I have to be fair to everyone. Is what I have to do. That's why I'm helping everyone. Okay. Yes.
Well, yeah,
a
but
Boncoin
you're-
celebration. Thank you, dude. Thank you. You're good. Ethan, chill. Okay. Cubert, this last one here, right? The graph of a linear equation passes through these points, right? I just
Yeah.
wasted so much of your time. No, it's okay, Jamarcus. Don't worry about that. Okay. -4, 1. That's this one, right? And 4, 6. 4, 6. 4, 5, 6. Okay. Which of these points are also solutions? Use the graph if it helps you with your thinking. Okay, cool. Do you know what this means? Do you need help with this?
Yeah. I don't know what that means.
Okay. It means, so a line that contains these 2 points, right, is going to look something like this.
Oh, I think I
Okay.
know. It's asking
Okay.
what the wider step is, basically.
No, it's asking for, well, it kind of is. Yeah. So they want to see which one of these points lies on this line. You can do this graphically. You can. So you can do what I did here, right? Where I graphed the points and I put a line in between them, right?
Yeah.
Okay. And then I can try to see, for instance, okay, cool. Does -6, 0 fall on it, right? 1, 2, 3, 4, 5, 6. We're like, ooh, it kind of does, right? That one kind of does, right? You kind of see it. All right, good to see you, Jamarcus. 8, 5, right? 8, 1, 2, 3, 4, 5. That doesn't fall on it, right? Nope. This one's nope. That's a nope. So this one doesn't. And then, yeah, 0, 3.5 kind of looks like it does, right?
Yeah.
And then, well, and here's where things get tricky, though, right? 12, 11. Like, where is that, right? I don't even have that out there, okay? This is where it helps Cuber to know how to create an equation from these 2 points. Do you know how to do that? Do you know how to create the equation of a line from 2 points?
Y equals
Mm-hmm.
we do 1 minus 6, so
Okay, good. Okay.
negative.
So it's y is equal to mx plus b. This is what's called slope-intercept form. But yeah, I know what you're doing.
Yeah.
We need to calculate m. M is the slope.
I think it's 5/8.
Okay, yeah, it is. Because what you did, right, is you did 6 minus 1 over 4 minus -4.
Yeah.
Right? So y minus y over x minus x. 4 minus -4, right? That's 8. This is 5/8. Okay, cool. So you get y is equal to 5/8 x plus b. How do I figure out what b is?
You see where the graph lands on the 0 for the x.
Let's say you didn't have the graph. Let's say you only had the numbers. Let's say you weren't allowed to graph it. Do you know how to figure out b just using these points?
You could make a table.
Could make a table. You could also use one of these points and plug it back in here. Okay. Do you see 4, 6? What is this for? Which point does that correspond to? X or Y?
Y.
No. This is x.
Wait. Yeah, it's
And what is the 6?
Y.
Y. Okay. All right. So I'm going to plug these into here and see what happens. Look, 6 is equal to 5/8 times 4 plus b. Okay?
Okay.
So all I did here, right, is I took what the x coordinate was for one of my points, I plugged it in, and I took the y coordinate for one of my points, and I plugged it in. And now I have an equation that I can solve for b.
So 20/8. So
Good. 6 is equal to 20.
2.5.
20/8. Yeah, which is 2.5. Yeah, look, 2.5 is showing up again, right? 2.5 plus b, right? So what does b equal to?
3.5.
Yeah, subtract, right? So b is equal to 3.5. So now what you're going to do, Cuber, is you're going to take this and you're going to run it right back into your original equation. So now you have y is equal to 5/8 x plus 3.5, okay? This is your equation of your line, all right?
So that's 3.5. So y-intercept. Yeah.
Yeah, do you see how that's the y-intercept? Because here's the cool thing, right? So these points here, Cuber, are on the line if when I plug them in, I get a true statement. And so what I mean by that, let's say we took this one, the 0 and the 3.5, right? If I plug in 0 for x, right, and 3.5 for y, see how this is the x coordinate and this is the y coordinate? What do I end up getting?
Wait. 3.5.
You get 3.5 right here, right? What's 5/8 times 0?
0.
0, and then plus 3.5. Do you see how I get 3.5 is equal to 3.5?
Yeah.
Yeah. That's a true statement, okay? So and because that happens, we say that this point is on this line, or that this line does describe this point. You're welcome, Jamarcus. Peace out. Okay?
Wait, so how do we figure out if 12 and 11 are
Well, let's check. So, again, which coordinate is the 12 for?
x?
X, good. And then which coordinates for the y?
11.
11, good. So I got 11 is equal to 5/8 times 12 plus 3.5. Okay, so let's check this. Let's see what happens, okay? So this gets me 60/8 plus 3.5.
So that would be
Yeah, so what's 60/8?
7.5.
7.5. Okay, good. What's 7.5 plus 3.5?
11.
Does 11 equal 11?
Yeah.
So that means this point is on the line.
So there's 3 on the line?
There are 3. Yeah. So there is, right? There's what? There's this one, and this one. Does that make sense? Does that make sense how we would do that?
Yeah.
Cool. Awesome. Great. Good questions there, Cuber. I appreciate them.
Thank you.
You're welcome, dude. All right, Ethan. What's up? What am I helping you with today? What's up?
And so this one might be a lot more easier for you than what we did yesterday.
That's okay. I don't care if it's hard or easy. What's up?
It's called bearings of an angle.
Bearings of an angle. Okay. Is that like north, south,
Just
east, east, west stuff?
Yes, not something. It's something like that.
Okay.
See, like that.
Yeah.
See, that might be easier for you, but I really don't understand how you find an answer.
It's so
Like, if
weird
they
that they
want you
do.
to find the
Bearing of B from A is 50 degrees. The bearing of A from B is 230. Is it 230? Oh, it is. Okay. That's cool. Kind of weird. But okay.
That's
All
all
right.
right. I need you to help me. All right. Is there
I-
any technique that I could use to remember?
I think drawing these compasses usually helps. Wait, what are they saying?
No.
Why are they saying 230? Why are they just not saying 130? Why does it go the other direction? Sorry, what? Ugh, this is such a weird thing. What's the difference between bear? I would just say I would just say north of south or south of east or something. Like what? Sorry. Quadrant bearing is that. The true bearing is that. Oh, do angles go clockwise from north? Is that how these work?
Yes, that's how it is.
Oh. That's cool. Useless. But yeah, that's cool. I mean,
What?
it's useless in math. Like, we don't really use bearing, but yes, okay. Okay, whatever. It's okay, Ethan. This isn't too bad, man. This is just, you know how we usually measure angles, right? How do we usually measure angles? Like, watch. Let's say I wanted to
It
say,
depends. What?
let's say angle A is equal to, I don't know, 150 degrees. How would I measure that?
Where's angle A?
I don't know, where is it? Or let's say vector A. Let's say vector A points at 150 degrees. Where would we say this usually points?
So it would be like hold on. Which one's east and west again?
No. Don't worry about any. I'm not doing east, west, whatever. I'm just saying 150 degrees. This isn't a bearing. This is just an angle.
Hold on. Then that should mean that it's somewhere on the right bottom,
Why do you say the right bottom?
right? Because because they're like making right angles.
This is 90 degrees, right? So usually when we measure angles in math, we start on this axis and we go counterclockwise is what we do. Okay?
But my class goes clockwise.
I know, that's for bearing. I'm getting to bearing. I'm just showing you how angles are usually measured. Okay. There's a difference between
Right.
There's a difference between angles and bearing. I want you to know the angle way because that's the usual way we measure things in math. So
All right.
this would usually be what 150 degrees is if we represent it in like math land, right? Where this would end up being 60.
Right.
Okay. And then there's actually a cool quantity here. Do you know what this thing is called? This angle right here?
Isn't that just kind of like wait, I don't know what it is called.
It's called the reference angle.
All right. And what's so special about it?
So the reference angle always connects an angle, or the end of the angle to the what I say is the x-axis. What it does.
Straight line.
Yeah, it's like it creates like this. This is called the reference angle. And then this is called like a reference triangle. This gets useful later when
Okay.
we start calculating, like, for instance, the sine of 150 degrees. Technically, this is equal to 1/2. And the way you're able to do that is through this type of math.
All right.
Okay. But okay. So usually we start angles here and we go counterclockwise. Bearing, however, starts at the top and goes regular
the north
clockwise.
direction.
You're right. Starts at the because this is usually north, south. Never eat. There we go. You know this one? Never eat soggy waffles. You guys ever learn that one? That's pretty fucking terrible.
Hold on. The east is to the right.
Yes. East is to the right.
Okay then.
Yeah. Because like in the graph of the world, right? Here's America. We're called the West, and then all over here in like China, right? We call this the East. It's another way to remember it. Like East China or like Eastern medicine, or like the Middle East. This is like the Middle East. It's where all the people are killing each other right now. That's East. That's over to the right. We're on the West. West side, best side, baby.
Now I feel like I got 80 on that exam because I had to figure out like two vectors perpendicular to each other. I mix up east and west.
Okay, it's all right. It's okay. You're not gonna mess up next time. Okay. So bearing, Ethan, is measured from this axis. Okay. So
Yeah.
if I have, for instance, something here, okay. This is the angle they measure. This is what's called the bearing. This is bearing.
Yes.
Okay.
I see that.
So, and maybe you see some like sci-fi films or something. They're like bearing 2, 3, 4, 6, blah blah blah. You know, like they're measuring the angle from you going straight ahead. I get it. I understand why bearing makes more sense probably in the real world. It's because you are usually heading wherever you are pointed at. You kind of is called like your north. It's like your true north. That's like your straight ahead is north. So east, right, is angles positive but to the right, and then they keep going until you come all the way around. What, for instance, would be this angle? Let's say we have here, and let's say I say this is like 45 degrees. We would say this is directly northwest, is what we would say. Okay? What would this bearing be? What would the bearing of northwest be?
45.
No. Bearing is
See-
measured
see,
from
that's where-
here. Bearing is measured from here, Ethan, right? So I have to come all the way around like this.
Mhm.
How much angle did I go through on the red here?
Well, if you include the west, then that's 275, and then if you add the if you
This is
add the
270. This is
45,
this is 270. 270.
all right, yeah, 270. I keep missing out.
It's
Yeah,
okay.
270, and then if you add the 35, then you
Uh-huh.
get 315.
Yes, dude. Yeah, 315 degrees. Cool. Does it make a little bit more sense?
No, but no,
fine.
not at all.
That doesn't make any sense? Wait, you just did it. What do you mean?
No, it didn't. It didn't. Hold on. That's what. See, they would do actual examples like that,
That's what I'm
diagram
doing.
right there.
Yeah, I'm fine. I'm fine. One sec. Something like this.
See, how am I supposed to figure out which is which?
Okay. Well, let's say here. Let's say the bearing. So A and B are 2 points, is what they're saying. Let's say like the bearing of B from A is let's say it's 90 degrees. Okay.
All right.
So let's always just draw like a compass. Just draw a compass, dude. Like just draw a nice fun little compass like this, right? So this is point A, right? Point A is here, okay? And I know that B has a bearing of 90 degrees, okay? So if this is A, right? North, east, west, south, okay? Where is 90 degrees? What direction does 90 degrees point in?
So wait, when is that really the compass right there?
Fuck, yeah, you're right. God damn it. Northwest, east, south.
Never,
Sorry.
never. So Dr. Go, you're telling me that now the abbreviation is
No.
never eat soggy.
Waffle soggy. Don't eat waffle soggy either. You know, don't do it. Yeah, sorry. I'm tired. We've been
still,
streaming
yeah.
for over an hour. It's an hour 45. Okay.
That's not a good excuse now.
What's the 90 degrees? Where's 90 degrees, Ethan? Show me.
North to east, right?
It's 90 degrees. So we start here and we go 90 degrees, which points me right in this direction. Okay?
Yes.
So this is point B. Okay? Now point B has its own set of bearings, right? Okay. Let's say I'm at B, Ethan, and I want to get to A, okay? How do I get from B to A? Which direction do I have to go?
You still have to go clockwise, right?
I do, but like in terms of like left, right, up, down, which way do I have to go?
To the left now?
Now we got to go to the left. Cool. All right. What is the bearing of this?
90 degrees.
Why do you think it's 90?
Well, isn't that true right there?
This would be 90.
Mm.
90 would be going this way. Right? 90 would be
270
just going.
I'm thinking
Yeah, it's good. It's
so.
270. It's
Sixty-
270. It's 270, right? See how you have to come
You didn't
all the way
exactly
around? It's exactly
I
270.
mean, I don't honestly. I don't really mind that.
Yeah. So here I would say the bearing of A from B is 270 degrees. Just think about it like a compass. It's just a compass, Ethan, is all it is. It's just a compass. Like, have you used a compass before?
No.
Compasses are great.
Wait, a compass?
Oh, you use one in math. I know what you're talking about. Not that type of compass.
Oh, not that one. Okay, no. Never use an
I know
actual
this is
compass.
the type of you've used this type of compass, right? This one.
Yes, always. I
They're
just
super cool.
used it today. Yes.
Those are awesome. Actually, that was my favorite part of geometry was using a compass. Wait here. I just want like a bigger thing. I guess this is kind of whatever this will do. Yeah. So Ethan, this is kind of how it works. Okay. So whatever direction you need to go in is always measured from here. Okay. So wherever you're going.
Mm-hmm.
And do you see how the angles go from 0 all the way to 360? This is basically 360, right? That's how it works. Okay?
All right.
So that's what bearing means. So if you need to just go straight, that's 0 degrees. If you need to go to the right, that's 90. You need to go down, it's 180. You need to go left, it's 270. Right?
Yeah, I see it.
Cool. Does that make more sense?
Yeah, it does
Okay.
make sense.
Good. All right, I'm tired.
I'm clearly tired, but I can't rest.
Yeah, that's okay. All right, very cool. Thank you, Ethan. That was great. Okay, awesome.
I'll ask one more math question before my math exam.
When's your math exam?
Thursday, I think.
Okay.
Right?
Yeah, we have a stream tomorrow. We're gonna stream tomorrow. Asking math questions during tomorrow.
Alright. So that's also one last thing. Can I actually stop asking you the question if I could do it? If I could like announce the students?
Yeah, no, you can always do it. That's why you have the role. You can announce the students whenever you want.
Alright,
Unless I
well,
tell you
when
I'm
do you
not
think I
streaming.
announce-
Unless I tell the students you're not streaming that day. Unless I tell, yeah, if I make a prior announcement that I'm not streaming, then just don't announce it, right?
I mean, what you could do is send me a DM and then I'll notify the students about why you couldn't stream that day.
Yes, I exactly. Yeah, if I can't stream, I'll let you know, and you can let the students know. Is that cool?
Yes.
Okay, cool. All right, let me end out the stream 'cause I'm
But-
tired.
Wait,
I'm gonna sleep. What do you want, Ethan? What's up?
Never mind. I forgot.
You forgot. Okay, all good. Okay, cool. Thank you everyone for coming to office hours. Had a great time. Big, huge thank you to our top subscribers. Playmoat Sam with 24 months. 2 years of being a sub, dude. That's awesome. A subscriber, not a sub, but a subscriber. I appreciate that. Kev DeMac, 14, Habib 9, Sensation 6, Shifter 2. I think Pen Center's over there on the right. Pen Center just joined on our subs. And thanks again for our Discord server boosters, Ethan, Amog, Noise, Obama, Teacup, Al Prince. Appreciate you guys keeping us at level 3. It helps us out. It does.
Actually helped recently boost you because of
You
the
did.
nitro. The very
You did.
first nitro of 2024.
Pardon?
The very first nitro of 2024 is what I'm
Very
saying.
first Nitro of 2024, yeah. Yeah, no, I appreciate you guys for doing that. Our next stream is going to be tomorrow. It's going to be an hour later, so that one starts at 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. If you ever have questions, you can always, join our Discord, hit schedule, or here, I think I have this set up. Do I have this set up correctly? 3 Tuesday, Wednesday. Good. Yeah, I do have this set up. Okay, good. And that also has the live stream schedule on it. Cool. All right. What I'm going to do is I'm going to have us raid one of the other math channels. So if you have any other math questions you want to ask and I didn't get to them today, please stick around for one of the other math streamers here. They're always answering questions. They have their own Discords. Just hang around, say hi to them, Otherwise, I will see you guys tomorrow. Enjoy the rest of your Tuesday. Hope it's awesome. And that's it. Yeah. Okay. Peace out, guys.
You didn't raid.
Oh, I'm rating. Yeah, give me a second. Give me a second. It's rating right now. Or here, let me.
All right. Well. Oh yes. I'll be.
Well,
I'll be
or
sure
look-
to announce it soon.
Looks like Don's doing video games, so I'll send it to Danny. Danny's got math. Go watch some math with Danny. Danny's cool. It looks like he's doing triangles. We love triangles.
All right. All right.
Cool.
Later.
Peace.